Can I start? All right. Good afternoon, everyone. I'm glad you all showed up. I was looking at the agenda and I thought, oh wow, I'm in some competition, so I'm really honored that you all are coming to see me talk about ML.NET and .NET MAUI. So yes, there we are. So this is me. I am Pieter Nijs, I'm from Belgium. I work as a consultant at Zebia and I do all sort of stuff with mobile, cloud and AI. I speak regularly at conferences and I've written this book, The MVVM Pattern in .NET MAUI, so I highly recommend you all buying it, of course. I'm a Microsoft MVP since 2017. People still coming in, that's good, the more the merrier. So the talk, the agenda is quite packed. I'm going to start off with an introduction into machine learning. Then we'll briefly discuss what ML.NET is, followed by some demos. And near the end of the talk, right before we dive into the final demo, I'm going to explain you what ONNX is, because that is something that we will be using in the final demo. So I'm going to start off with showing the end result. So this is a working app, and it contains 3 tabs, and in each tab something machine learning-ish magic happens. So in this first tab, you can fill in some data about a loan that you are requesting at the bank. I've got a button here to fill in some defaults. So it's the amount of money that I want from the bank, in how much time, how much savings that I have. And when I press the submit button, I get a prediction that probably the bank will approve this loan request. So that'll be the first demo that I'm going to work on. Then in the other tab, this is about estimating yearly medical costs. So if you fill in some parameters, like for example, 43, male, BMI, let's say 24, number of children, true, region is Northwest, and I press submit, well, this is my estimated yearly medical cost. Also machine learning happening in the background, all locally on the device. And then the final demo, I'm a big fan of Formula 1, so I had to put something in there for Formula 1. It lets me pick an image of a Formula 1 car, and when I submit this, then the app will tell me that this is probably a Ferrari. Of course, this is a Ferrari, it's red, so it's probably is Ferrari. So it is all machine learning happening locally on the device, and during the talk we will have a look how we can build this. But first things first, machine learning. What is machine learning? Well, very briefly, if we look at classical coding, we have code that transforms input to output, and this code, we have written it. We have given the computer instructions, you have to do this. We have defined the rules. When looking at machine learning, well, it's almost the same, except it's not code that transforms the input to output, but it's a model. Now, what is this model? This model is something we have trained a machine learning algorithm by feeding example inputs and example outputs to a computer, and the computer has figured out by looking at these examples what the rules are. So that's basically the model, rules learned by data. When talking about machine learning, there are different problems that we can solve, like how much, is it this or that? Is this odd or not? What are the next steps that we need to take? And each of these problems map on different algorithms that the machine learning model will use. Now in this talk we'll be focusing on these first two, regression, which is predicting numbers, and classification, predicting a category. So regression and classification, when talking about machine learning, we often refer to properties or whatever as features. So we're going to use features, or X, to predict a label, Y. And with regression, this label is, as I've said, a number. It's something continuous, like house pricing or temperature, while with classification, the label is categorical. Yes, no, blue, green, yellow. Now, with classification, it is both possible to do multi-class or multi-label classification. What do we mean with that? With multi-class, the result will be one category. So that means that the prediction is the one or the other, so not both at the same time. While multi-label, there it is possible that multiple categories can match, like it is sunny and windy at the same time. That's perfectly possible. Now, once we have a model, how do we know how well it performs? Well, we can do that with unseen data. Unseen data is data that the model hasn't looked at during training. And typically, if we have one data set, we typically set aside like 20% of our data and keep that aside and let the model train on the other data. Or if you have a separate data set, you can also use that, of course. Then, once we have a model, we can feed in that test data to the model, look at the prediction that it makes, and then we can compare it to the actual factual values that we had from our data set. And that is how we can measure the performance of our model. And we can use different metrics for that, also again depending on the scenario where you're in, but we will look at that later in the demos. So now that you know everything about ML.NET, about machine learning, what is ML.NET? Well, it is basically Microsoft's open source framework to do machine learning inside .NET. So we don't need to switch to Python or any other programming language. We don't need to learn a new IDE, new ways of working. We can stay in our ecosystem and do machine learning right there. And so the cool part really is that it plays nice with all the .NET stuff. I'm going to show you how you can use these trained models in .NET MAUI. If you want to use them in Blazor, in ASP.NET, and a console app, it all works. Now, ML.NET basically has two sides. You have AutoML, which is a tool that generates models and code for you. You have the model builder, which is a GUI in Visual Studio, and you have a CLI tool. And then you also have the SDKs, which is basically a NuGet package that you can add to your project, and then you can write your own code to build your machine learning pipelines. We'll look at both these things in the demos. So briefly again, AutoML. It basically is the easiest starting point for machine learning. So you have your data set, and you basically say to AutoML, you figure it out. This is my data, and this is the column or the property that I want to predict. You go ahead. So it will try multiple models and settings, and it will just find the best model for you. So it's a great way to get started. Now, the downside is, of course, that it doesn't have domain-specific knowledge. So it might interpret stuff differently than what it really is. So then you have to tinker with it, of course. But the cool thing is that all that AutoML does, like generating the model and generating the code, the generated code is perfectly editable. So if you have a model and it isn't performing as, or you think it could do better, you can just have a look at the code, fine-tune it, adding some stuff, and then retrain the model again. So it's a perfect way to get started. So, and that is exactly what we're going to do in the first demo. So we're going to do the loan approval demo first, and that's a binary classification. So it's classifying true or false. And I'm going to do that with the ML.NET CLI. And using the ML.NET CLI is very easy. But let's first have a look at the CSV file that I have. So I got this data from Kaggle. Kaggle is like GitHub for data, basically. And it contains all sorts of information, like the requester, how many dependents they have, what their education level is, their annual income, and so on and so on. And at the end, we have a column indicating whether their loan request was approved or not. And so this loan status column, this is a column that we want to predict. And to do that, we just go to the terminal and we type in ML-NET classification, because it's a classification problem that we want to solve. And with the dataset parameter, we can point to our CSV file. Next, with the following parameter, I can indicate that it is the loan status column that we want the model to predict. Split ratio, like I've said, we want to put some data aside to do the evaluation of our model. So we're going to set 20% of our data set aside. With train time, we can indicate how long that the computer gets to do the training, 30 seconds in this case, which is quite short. We give it a name because it will generate a CS prosh with all the code in there. So that's the name for your project. And then also very important, with ignore calls, I can indicate which columns from the data set that it can ignore. So there was an ID in the CSV file, just an incremental integer. That's not relevant, of course, for predicting the loan status request. So let's just live on stage execute this in the console. And so you see now that ML.NET is trying different trainers, so basically different algorithms with different settings, and it's constantly measuring how well the model performs. And then after 15 seconds, it shows you the top 5 or so scoring models, and it also shows the accuracy. So 97% or 98% is pretty good. So, but that's just the starting point. What is the thing that AutoML has generated? Well, of course, the model itself, right? So the model that I can use in my code. But next to that, it also has generated the code that uses this generated model. Input classes, output classes, prediction engine. It has even, in a program CS file, it really has an example application on how to use it. It contains the pipeline, which is the code that was used to generate this best model. It contains code to retrain the model and also code to calculate feature importance, which we're not covering in this talk. So we will be looking now at the code that uses this model so that we can then take that code and hopefully port it to .NET MAUI. So this is the project. I'll zoom in a bit. So this is a generated project. And in there, of course, we have the mymlproject.mlnet file. This is the generated model. And then we got some files right here. And we're now focusing on the consumption.cs file. This contains a partial class, mymlproject. And in there, we have a class model input. I think the name speaks for itself. This is basically the input that needs to go to the model. And this is basically a mapping of the data that is in your CSV file. Number of dependents, education, self-employed, with data types that we know from .NET. It also has generated a model output class. So this is a thing that the model will output. It contains the same properties, because that's how ML or AutoML works. But at the end, it also has 2 additional properties: predicted label, so the prediction that the model has made, and then a float array containing the scores of the predictions. So model input, model output, we're going to use that later on. Then this class also contains a reference to the generated machine learning model, a MLNet model path. And you see that also in this class we have a lazy prediction engine. So the prediction engine is basically the thing that will do the prediction in the end. It is typically generated as lazy. And in the create prediction engine factory method of this field, you see that we're newing up a ML context. And there we're using the MLNet model path variable to really load the machine learning model into our ML context. And then we can simply say, okay, now I want to create a prediction engine where a model input goes in and a model output comes out, and use that model that was specified. And then it's very easy to use. So there's this generated method predict all labels. And so it will take the instance or an instance of the prediction engine. It will call predict on the input that was given. And the result will be a model output instance. And then it goes to other .NET methods to transform this data to ordered enumerable of key value pairs, so that we have the predicted labels with the confidence score. So that's basically what AutoML has generated. How can we now use this in .NET MAUI? Pretty simple. The first thing that we need to do is add 2 NuGet packages to our .NET MAUI app, Microsoft.ml and Microsoft.ml fast tree. And then, this is very important, we are going to disable a platform check. So out of the box, iOS devices are not supported. So if I would build this for iOS, I will get an error saying, you're not allowed to do this. I just YOLO, I disable this check and everything works. So it's all fine. And then once that configuration is done, the next thing I do is I just copy over that generated model to my .NET MAUI app. I put it in the resources raw folder so that I can use it inside my app. And then we can just start copying over code. Model input class, I just copy that over from the generated output from AutoML. Model input, model output, I copy that over. Then I create a new class, load the loan prediction engine. And also there I copy over the code that we just discussed. But here's a little bit of a pitfall. It contains this reference, this path to the my ML project model. But of course, inside MAUI, it is unable to resolve this path. So I need to work a little bit around this. And I've done this by introducing an init method. And this init method allows me to pass in the path to the model, and then it can load the model. Now, there's another pitfall. For those of you who work with MAUI, you might know that on Android, if a file is in your resources raw, so it is embedded in your application, you can't just treat it like a normal app at runtime. On iOS, you can do that. So you have to copy over that file to the file system of your Android app, and then you can work with that. So that's why I have this check. If this is Android, I'm copying over the binary the binaries from that baked-in file, and I'm copying it over to the file system. What I get back is the path where it is located on the file system. And then eventually I can just assign MLNet model path to the path. On iOS, it is a lot more simple, and I can just assign the given model path right there. And basically, the entirety of that class is the same like I showed you as it was generated. Now, using this on your page, super simple. I can new up a new model input, gather the information that the user has entered in the app, That's what we do right here. Then I call my init method that I just created. Once I have done that, I can call predict all labels, passing in my model input. And what I get back is just a collection of key value pairs. I can search for 1, so the positive, take the value to show the certainty to the user. So I can do with those values, of course, what I want. I use them. I navigate to another screen and pass those values through. Now, just a quick note on that init method. It isn't the prettiest, I know. It's a little bit dirty, but I have done this intentionally for this talk, just to show you that basically it's copying over stuff and then introducing that init method. That's all. It can use some refactoring, but I don't want us all being strangled up with refactoring stuff. So, but it works like this. So that was the first demo. That's how that first page works. So pretty simple. So how can we train our own models with code? So instead of AutoML doing all the magic, how can we create our models ourselves? So we're going to get our hands dirty. We're going to write some code. For that, just create a new console application, add the required NuGet packages, define an input model ourselves, an output model, create a pipeline. This is not the YAML pipeline, so we're all good here. Don't be afraid. Then once we have a pipeline, we can train the model. We fit our data on it. And then we can evaluate the model, save the model with the pipeline, and then again use it in our app. And we're going to do just that. So if you remember, the second page in the app was about estimating yearly medical costs. So this is a regression problem. It's a continuous number that we're searching, that we're estimating. And for that, I also have a CSV file that I got from Kaggle, and it contains information of patients. It contains age, sex, BMI, and so on. And at the end, the medical cost column, the column that we want to predict. So we're going to train the model ourselves. I've created a new project. It's a console application, and I, of course, have added the NuGet package Microsoft.ml. Then I'm going to create my own input model. But that isn't hard or anything, because this just maps the data that you have in your CSV file or whatever file that you have. You're just mapping that to C#. So I have age, sex, BMI, children, and I'm using the data types that I know from .NET. So that's that. And the output model, very simple. We are estimating a number, so we can just put one property in there of type float, medical cost, because this is the thing that we are trying to estimate. Now I'm going to build my model trainer. So this is just a class that will do the orchestration for training my machine learning model. First, some boilerplate stuff. I got a constructor here accepting a data path. So this should point to the CSV file that contains the data. And the second parameter indicates where I want to store the generated model. And in this constructor, I'm also newing up a new machine learning context. Then the train model method. The first step in this method is we're going to load our data. And loading the data is pretty simple. We can basically use the ML context, call data.load from text file, and then point it to our CSV file. That's all. It will return an iDataView, and iDataView is a data type that we will be working with throughout our pipeline. iDataView is basically a table, so with rows and columns where our data is in. So yeah, it's basically a spreadsheet. Then, very important, we also discussed that after I've loaded the data, I want to immediately set aside 20% of my data that I will be using to get to do the testing of the model later on. And also for that, I have simple methods in ML.NET. I can do train test split. I pass in my iData view, so it contains the data of my CSV file, and my test fraction in this case is 20%. So I'm setting aside 20% of the data. It is returned as a tuple, and I also return it here as a tuple. So once we've done that, we have training data and test data. Then now this is the moment where we all have been waiting for. Now we can start building and training our model with our trained data, of course. And so we have to create a pipeline. Okay. A pipeline, I always see it as a conveyor belt. So we define stages, and once we have defined our stages, we're going to put something on the conveyor belt, and every stage will do something to the product or the data or whatever, and what comes out will be the thing that we would want to have. So this is basically going to transform our data, and the first step that we're going to do is one-hot encoding. Now, what is one-hot encoding? This basically turns categorical values into vectors, into binary vectors. Why is that? Well, these machine learning models, they work with numbers. They don't work with text, of course. So we're going to transform data into binary vectors. Why don't we just assign a number to cat, dog, bird? Why don't we do that? Well, then you are basically defining some sort of relationship. A model might then assume that a dog is bigger or larger or more important than a cat, and that a bird is close to a dog but not so close to a cat. Doesn't make any sense. There is no numeric relationship between all of these. We just need to make sure that they are treated as individual things. That's why we work with these binary vectors. Okay. One-hot encoding, I'm going to do that for the region property, which was text. And so the encoded value, I'm going to store that in a new column in my iData view. So that's a cool thing about this iData view. I can just start adding columns. I could also choose to overwrite the existing column, but I prefer to store my manipulated data in other columns. I do the same thing for sex and the same thing for smoker. So that's one-hot encoding there. Then the next thing, I said these machine learning models work with numbers. Well, they work with floats to be exact. And I've got children and age properties. These are integers, so I also need to explicitly convert them. So I'm going to convert some properties. Like I've said, children, I'm going to convert them to singles, so to floats. And I'm going to store that in a new column, children float. And I'll do the rest the same for age as well. There was another property on my input model as well, which was BMI, but that was already stored as a float, so I don't need to explicitly convert it here. I can do that, it's probably safer should my model update or whatever, but it's not needed. We're almost there. What we're going to do now is we're going to concatenate. So if we have manipulated some data, we have to prepare the data so that a machine learning algorithm can work with it. What we're now going to do is all these columns, we're going to take them together. We're going to concatenate them in one large binary vector. That's what concatenate does. So we're going to take all these encoded values and BMI, and we're going to combine them in one column named features. And then it is regression that we're doing. Finally, we're telling the pipeline, okay, I need a trainer or a algorithm. So I can go to regression.trainers.sdca. It's just a random algorithm that I have chosen. And I tell it, the medical cost column, that's the thing that I want you to predict. And you use the features column, so this big vector, you use that to determine these things. So that basically until then, this is my pipeline, but it's like lazy. It's like an iQueryable where I don't do a to list on. It is only when I call .fit that the pipeline is really created. And when I pass in training data in this fit method, the result will be my working model. So that's basically the code that is needed to train this model. Once I have a model, the next step, of course, is evaluating that model. But also that is pretty easy to do with ML.NET. So I have a method, evaluate model, where I can pass in my test data and my generated model. And so I can, through the ML context.regression.evaluate, I can pass in my test data and say, okay, you have to look at the medical cost column. This is the column that you need to predict and where you need to compare to. What comes out is a class which contains some specific metrics. So speaking of these metrics, there are a lot of metrics when talking about machine learning. But there are two where I just want to focus on here today in this talk. You have the mean absolute error, which is the average absolute difference between the predicted value and the actual value. The cool thing about this is this number is at the same scale as the value that you want to predict. So it really means something. The R-squared metric, it explains the variance, and it's a number between 0 and 1, where 1 indicates a perfect match. So keep these two metrics in mind, because we're going to look at them in just a second. So finally, at the very end of my model trainer, I'm going to save my model. So I'm going to save the trained model so I can use it later on. And then in my console app, I create a new trainer, passing in the path to my CSV file, passing in a path to where I want the model to be saved. I call train model, and all the magic happens there. And we're going to just run the app right here. And then I'm going to zoom in. So mean absolute error, as I've said, at the same scale of the number that you want to predict. So it varies 250, give or take, dollars, which is pretty good because yearly medical costs, especially in America, are thousands of dollars. So 250 on average, I think it's pretty good. But have a look at R-squared. Remember, between 0 and 1, where 1 indicates a perfect match, well, I've got 99%. So that's pretty cool, actually. I was surprised myself when I first saw this, so I think it's pretty cool. All right. So we have this zip file now generated, not only containing the model, but it actually also contains the pipeline that I've created. Why is that? When I'm going to use the model, I'm also going to pass in my input data, and this input data also needs to be treated the same way as my training data was treated. So that's all inside this zip file or ML.NET file, whatever you name it, doesn't really matter. So again, I add this to the resources of my MAUI app. I again copy over input model, output model. I copy it over from my training program that I had, and then I can create my medical cost prediction engine. This looks a lot familiar as what I showed earlier. Again, an init method where I do the little magic just for Android's sake. And I have my prediction engine. I have the create predict engine factory method. It's all the same like we had in the earlier example. And then finally, a static predict method, which allows me to pass in an input model. I call prediction engine.value.predict, and I just return the output model back to my mobile app. and then using it, again, very simple, initializing the input model, using data that the user has entered on the screen, calling the init method of my medical cost prediction engine, pointing it to the zip file that contains the model and the pipeline. I can call predict, and then I can just read the medical cost property from my result and show that on a screen. Okay, let's move on to the final demo. Let's quickly discuss ONNX. ONNX is Open Neural Network Exchange, and it's developed by Microsoft and Facebook, and it's actually an open format to save and share machine learning models. There's also an ONNX runtime where these converted models can run on. So that's very interesting, but why are we particularly interested in that? Well, that is because ML.NET directly supports ONNX. So if you see an ONNX model somewhere, you can just use it in .NET using ML.NET. And I said seeing an ONNX model somewhere, yeah, where can I see stuff like that? Yeah, typically in a zoo. You have an ONNX model zoo, which is a GitHub page that contains already pre-trained ONNX models for you. Custom vision, natural language processing, you name it, they have it. You can just download them and use them in ML.NET to do the thing, so you don't need to reinvent the wheel yourself over and over and over again. So it's great for prototyping or building on existing solutions. Okay, Azure Custom Vision. Azure Custom Vision is something interesting. It's been around for a couple of years. With Azure Custom Vision, you can actually train your own custom vision machine learning models. You can host these models in Azure Custom Vision, so you get a REST API endpoint, but that's not where we are interested in. So we're going to have a look at how we can take this model that was generated and use it locally in our .NET MAUI app. So we can create a new project here. We can give it a name, a description, whatever, and then you have to point it to one of your Azure resources. I don't know by heart which resources you particularly need, but there are wizards here if you don't have anything set up to get everything set up. Now for this custom vision, there are basically two things that you can do, or classification. So it will classify an image. It will say it is this, or that. But you can also do object detection. So if you have, for example, pictures of balls or whatever, and you want to identify the balls in the picture or in the room or whatever, you can make sure that it doesn't only recognize that there are balls on the picture, but it would also give you coordinates of the bounding boxes of these objects. So this is also something that you can do. For our use case, I just want to do classification. So I want to send a picture of a Formula 1 car to the model, and it must tell me from which team the car is. Then, once you have selected classification, you have to also specify the classification types. And I mentioned that at the beginning of the talk. You can have multi-label or multi-class. With multi-label, you can have multiple tags per image. With multi-class, there's only one. Then you need to pick the right domain. There's this link here down below, which you can click to get more information about these different domains. But we are particularly interested in the domains that have compact in their name. And why is that? Because when I click on it, I get export capabilities. And ONNX is right there. So we can train a model here on Azure in Azure Custom Vision. It will take some time to train, but once the model is done, once it's done, you can download it, and then embed that in your application. And that's exactly the thing that we are going to do. So I'm going to create this project. And now the fun thing starts. Now you have to upload images. I have to make sure I have the right images right here. Datasets, F1 cars. So I'm picking a couple of cars right here. And I can, if I want, immediately tag them right here. So I now only selected Ferrari cars, so I can instantly also specify that these are Ferrari cars. I don't have to specify a tag here. I can do that later on as well. So I'm gonna name them Ferrari, upload them, and I can do that for other cars as well. So McLaren, for example. Upload these files, and I can do that for as many categories as I see fit. Now I'm only uploading 12 to 11 images. That's way too little, or way too less. Really make sure that you are ballpark 50, 100, that you have something like that if you really want to have a good performing model. So that's that. Once I have submitted all my images right here, I'm going to leave it with Ferrari and McLaren for now. I can click the train button here, click train, and it will kick off and it will do its thing. I'm not going to do that now because I don't know how long it might take. But I've done some preparations. So in this project, I've uploaded pictures of 4 teams, 4 Formula 1 teams. The training is done. And so now I can click the Performance tab. And here in the Performance tab, you get already an indication of how well the model is performing. It's not the best, but it's just demo purposes. And you can see even down below per tag, per category, how well it performs. So the precision, what the recall is. But as it's indicated right here, 43 images is way too less to do stuff like that. So I can either publish it so that I get a REST endpoint to where I can upload the image, but that's not what we are here for today. We can also click export, choose a particular format, ONNX in our case, because that runs on ml.net, and then click export. What you basically download is the ONNX model, of course, and also some metadata. And there is also in the zip file that you're downloading, there's labels.txt file containing all the labels that the model is able to predict. And we'll have a look at that in just a few seconds. So I'm not going to download it right now. I already have it. Now that you have your model, or when you have downloaded ONNX model from ONNX Model Zoo, how can you now use it? Well, there's a really cool website for that called the Netron app. And with the Netron app, you can actually have a peek inside the ONNX model. Have a look at what's going on. And I'm going to pick my model. So this is my ONNX model. I'm going to upload it. And so it gives you an overview of everything that happens inside the model. Why is this interesting? If I click this first node, I can see what data that the model expects as input. What name it expects as the input parameter. What data type it expects. This data type might seem a little bit strange, but it's actually pretty simple. It is one image, hence the 1, 3 channels, RGB, and the pixel needs to be the image needs to be 300 pixels wide and 300 pixels high. So that's basically what this says right here. And we need to have that information so that if we later on construct our pipeline, that our data is exactly transformed to this data type. Then the output, come on. Also important, the name of the output variable will be model_output, and the data type that will be returned will be a float, so containing the what it predicts. And the 4 indicates that this array will always be 4 items long. Why is that? Because the model is trained to predict 4 categories. So you will get a prediction for each of these 4 categories. So very interesting, this website, to have a look at how you can use such an ONNX model. So let's just do that. Let's take this model, bake it in the app, and see what we can do to do this offline analysis. The first thing is, of course, I need to add some NuGet packages. Microsoft ML Image Analytics, Microsoft ML ONNX Runtime, and a couple others. This one is a very important one. This is an expensive line of code. If you don't have this, it will not work on iOS at runtime. And then you're searching what is happening, why is it not working? Because of that. It's not documented anywhere, not that I could find. But once you add that one, extensions, yeah, then your iOS build works. Okay, so very important. Next, like I've said, the zip that we downloaded contains labels.txt file and the ONNX model. And as you can see, labels.txt file, I'm adding that to my project as well. So it contains the 4 categories that the model is able to predict. And now this perfectly maps on what the model will return. So it will return an array of floats, 4 items exactly. And so on index 0, I will get a confidence score that the car is an AlphaTauri. And on index 1, I will get a confidence score that the car is a Ferrari, and so on and so on. So both labels.txt and ONNX are in my app, again in the resources folder. Then to use this, again, we need to create an input model, and when working with images, there's a special data type, ML image, that you need to use. Also the attribute, important, the 300, it corresponds with the fact that the images need to be 300 pixels wide and 300 pixels high. And then the output model, as I've said, it's a float array, and here, important, the column name attribute, this maps on what we saw in Netron app, where it indicated that the output variable is named model output. So that needs to map. Now I'm going to create my F1 car prediction engine. Well, we've seen that before, an ugly init method. And it now also allows me to pass in a labels path so that I can specify where it can find the labels. Again, on Android, I'm copying it over. But in the end, I'm going to read that labels file and put the lines in an array of strings. Now the create prediction engine method looks a little bit different. So I am creating an ML context in the method itself. And now I'm creating a pipeline, not for training the model, but for really using the model. So, and the first thing that I'm going to do is I'm going to resize my images. Remember, these parameters that go into the model needs to be exact how the model expects it to be. So I'm going to resize my images 300 to 300 pixels, and I'm going to put that in the column resized image. Then the other thing that was visible in the Netron app was the fact that it needs to have 3 channels, RGB. And I can do just that with the extract pixels method. So this will basically extract the pixels and put it in 3 arrays of RGB colors. I'm going to put that data in the data column. And then finally, so it's a pretty short pipeline. Finally, so I've prepared my data. Now I'm going to call my ONNX model, passing in the path to the model. And it will use the data, so the transformed image, to do the prediction. as I've said, pipeline is a lazy thing. I need to call fit on it, but now I don't call fit on it to train the model, but just to initialize the pipeline, and I can do that by just passing in an empty list for as a parameter. So then ML.NET also knows, oh, this is not for training, this is really for using. And then again, like we've seen before, create a prediction engine specifying input model, output model, and that's basically it. Now I can call the predict method on this F1 car prediction engine. I'm going to pass in a stream of the image. From a stream, I can create an ML image. I'm passing this ML image as a property of my input model. And then I get back a result. And then I'm going to use the labels array that I have just to make a dictionary so that I get my categories and their predicted score. So pretty simple once you see it working. Using it, again, dirty init method. I'm going to read the stream from an image, and then I call F1 car prediction engine.predict, passing in the stream. I get back a dictionary. I'm going to take the highest value, the highest predicted value, and so then I can use the key and the value to show on another screen. So that's basically it. Once you see it there, the code, it is pretty simple, but making it up is not always that easy. And so with that, we come to the end of my talk. If you scan this QR code, you can find a link to the entire presentation and to all the codes and other interesting bits, but only after you have filled in a short feedback, of course. If you have any questions, you can ask them now. You can approach me. I'm here today, tomorrow, or via the Q&A, which you can also find by scanning this QR code. And with that, I would really like to thank you for your attention and have a nice day. Thank you. Any questions? Everything clear? There was an okay.
Yeah, the question was, do you have a use case or like a nice project to tell about where you use this offline model?
Yeah, so I have a project, but I'm unable to give you any information about that. But it was basically like scanning values of machines that needed maintenance or potentially needed maintenance, and using these values to make a prediction whether the machine needs to have maintenance in the coming weeks. Any other question? Okay, thank you.